Today I want to talk about hyperfast programming. I have actually written a book that is called Hyperfast Herminator, and the fun thing about that is that at one bank where I was working, they called me Hyperfast Herman, and at another place where I programmed a huge chiropractic practice management software very fast, they called me Herminator. All right, so this is Hyperfast Herminator. Good. Now, I have done this. I have written a lot of systems very, very fast, and many of these systems have generated millions in revenue. They ran for a long, long, long time, and often very large systems that are much larger than what you would normally give to a single programmer. So let's see what this is all about. First, to get an obvious thing out of the way, fast programming is not really only about typing faster. Of course, it helps if you need to be really, if you're slow on a keyboard, you don't get much stuff done. So my recommendation is that people get really familiar with their keyboard, because ideally you should be able to reach everything where it is with just touch typing. So you don't need to look at the keyboard, well, where's my 7? But you can do that with touch typing. And you could, for example, play a computer game for touch typing to learn that. And the recommendation is get a good keyboard. And ideally, it should be the same keyboard that you're using on all your machines. If you have a laptop that has a small dinky keyboard, and at the office you have a big keyboard, then try to use your laptop also as much as possible with a big keyboard, because you don't want to have friction of where is the keys. The other thing that I find is very important is having a second monitor. It's estimated that you are about 20 to 30% more productive at least if you have a larger monitor. Nowadays, it's very easy to get a 4K monitor, and ideally it should be 32 inches or larger, because then you can design, let's say you program, you can see the design, how it looks visually on one side, split the screen, and you can put the code onto the other side. It's much faster to flip your eyes between two things than to flip it on the keyboard or to think about, well, what was on the other screen. The eyes can move so fast, and that will really speed things up. All right, let's get into the actual principles of programming. Now, one of the first rules I found is that the fastest code is code that doesn't even exist. There are situations where maybe you can have the framework do some work that is already done, or there could be situations where you don't even need something. And so code that is not written cannot break. And it does not need maintenance. And also, if the code doesn't exist, that typically has no programming errors. So it's a very handy way to keep that in mind whenever you program something. Does it need to be in there? All right. The next important thing is to decide ahead of time what you code. Just typing and then trying it out is not that smart. Often, if you do some 10 minutes of thinking before, that can save you a lot of time in coding. So you don't want to just do typing and thinking kind of at the same time. So get a good concept of what you're trying to do to start with. The next rule is reuse aggressively. Of course, the longer you are working in one programming language or a programming system, the more possible it will be for you to reuse code or screens or layouts or entire workflows. And of course, especially your own systems. So there you know already exactly what you've done before. Reuse the stuff and you get much, much faster going. And there will be more about that later in the video. Here was an interesting quotation from Steve Jobs. Steve Jobs says, "Good artists copy, great artists steal, Well, and of course, the easiest one to steal from is yourself, and that's certainly much, much faster than reinventing stuff. Another very important rule is simplicity. Keep things extremely simple. Some of the best university programmer professors say that the simplest solution that could possibly work in computers is often the right solution. Try to keep things simple. You don't need to do something that is so complicated that your professor at university would be impressed. Your professor isn't there anymore. And so instead, you're writing systems that are easy to understand, and there will be less problems. Important also to use the tool that works for you. So if you've used it a lot and it worked for you a lot, that is often faster than trying to use the very latest and greatest. Maybe with the exception of AI. AI is probably one of the most recent things that came in where it is faster to use it than not to use it. So new normally is not always better. Here, come up with a good balance between something that is not just fast to build, but you also must be able to change it and to fix it and to extend it. It should be easy for you to understand it, even late at night, or maybe somebody else ideally, or AI when you want to show it to that. And then you have code where you don't have to be afraid that it could be breaking any time. If you have code that could break any time, that will automatically make you go very, very slow and carefully. Here's what we mean with tight feedback loops. So the idea is that you code something and then you can see immediately how does that look like. That's why you want to have the big monitor. On one side, you have your program code. On the other side, you can see what's the output. So you change a little bit of code here, press the button, and then you can see, that's how it looks. And so basically, there are systems where you don't have to go through any complicated pattern. And ideally, that will speed you up a lot. Make it so that you can just type a little bit and see it immediately. Don't wait for complicated compile times. Another important factor is to stay in one mental context. You don't want to be looking between two different language universes, between two different or more different projects at the same time. Try to work on one thing in a day, and then don't switch between 2 or 3 or 5 different projects. So also to try to use different languages at the same time, not that smart. So the more continuity you have, that will give you definitely speed. I'm getting asked, do I use AI? And the interesting thing is, yes, I use AI, and I use it actually a lot. But what I'm finding is that it's very smart in getting stuff done, especially if you follow these kind of guidelines. The idea is, don't say, well, my entire project is so-and-so, please write me the entire project. There could be errors all over the place, and it will be very, very difficult to get that stuff fixed. But instead, you give it small tasks and stuff where you think that it can complete the whole thing. These have to be tasks that are small enough that you can see whether it is successful. And these blocks basically can go in there. And if you have a language that's, let's say, data-centric, rather than a lot of memory variables and hundreds of lines for nothing, then AI comes up with relatively small blocks of code. 20, 30, 50 lines of code that is easily fitting onto one large 4K monitor. And so it makes it much, much easier. You don't want to get a monster piece of code and then you don't understand it and you certainly cannot find the errors. So keep the chunks that AI works for you small, and that will speed things up a lot. For a long time, I was a strong believer in everything that Microsoft made. And the problem with that, though, is that they always come up with new stuff. Every year, they show what their thousands of programmers have created that's now totally new, and you would typically spend about that year to learn everything that they made, and then the problem is the next year there's everything new again. So it is better to go with stuff that has worked for you, that you can understand, and that is stable. You don't want to have surprises that seem to come out of nowhere. And here's an interesting test. Can you read and understand the code at 3 a.m. at night? So ideally, the code should be clear enough so that you can see what it does, even if you're not at your totally most mentally alert time. So write a code that you can see it clearly and that other people can also understand it. Sometimes I wrote code that then ChatGPT commented and said, well, yeah, that seemed like a bright idea at the time, but it does not work very reliably. So write code that is easy and clear. Do things that belong together in one sort of batch. Let's say you're working on changing the user interface, then it's a good idea to do all the user interface changes together at one time. And instead of doing some coding, some UI changes, some this, some that, so try to do stuff that belongs together in one swoop. Let's say you have to write 3 reports, then write those 3 reports together, and the next user interface screen change, and do those together when there's a bunch of those. Sometimes to get going, it is necessary to take some sort of what seems to be a temporary solution. Let's say you have some coding, some hard-coded whatever password or something. Temporarily, if it gets you faster, then it's okay to put that in there temporarily. Just remember what was a temporary solution at that time so that you keep the momentum going, and then you can finish that later. Maybe you take the password out of a specially encrypted key or something. But you have to remember, temporary stuff may get you faster at some time. Here, protect your energy. Basically, work in bursts, don't go into burnout, and just keep steady at the work. That will lead in heroic type of performances overall. This is a very important point. Build systems that build systems. So when you write a system, think about what could be reused in the future. What could be like a generator for certain reports? What could be a screen layout template, or maybe a Word emailing template? And so you write in a way that you can have reusable components, and ideally even systems that build systems. For example, I wrote a huge medical application that had for over 100 employees, and they had 30 different workflows in the place. And so each of them needed to have their own complicated set of screens. So I wrote a special screen generator where we could just fill in a bunch of parameters, and that it would then use those parameters to generate the entire screen. And then those generated screens could also be used for reports. And basically, this was a system that builds entire systems. So that is an important part and can help in a lot of speed. Of course, that also goes better if you stick for a long time with the development platform that you're using. If today you're using C++, tomorrow you're using C#, then you're using something else altogether, and the next project yet something else, then you cannot reuse anything. But ideally, you should be able to reuse stuff. And don't get systems that you get from others that are reusable, but are so complicated to learn that it might have been faster for you to write them from scratch in the first place. Okay, these are a lot of different points. There are actually a couple of more that you'll find in my book. And I'm going to expand this video probably fairly soon again as well, because I'm just thinking of more that I could have mentioned. Let me know if you have any particular questions on what to do, Let me know if there's any system that you need to be built very fast. Like I said, there were some systems I could put together that went live within days. There was a huge financial system that I wrote at some point that had a lot of programming that was highly reusable. Then the next project I worked on was a dating site, completely different from an accounting system. But because there was so much reusable stuff that I could borrow and use from the previous system, I went live with a dating site in 1.5 days. And that system is still around today, 25 years later. There were some other crazy examples. I will mention them at some point, but for now, let me know what you think and what questions you have. We'll talk soon. Bye-bye.